Bash generally interprets anything on the command line to be text, and unless you tell it otherwise, it interprets anything that comes out of commands to be text. So when it does substitutions for special characters on the command line, it looks at them as text and substitutes text. If we do a command like echo 3 plus 4, we haven't told it anything special, so it treats everything on the line as text. The 3 is a text character, the plus sign is a text character, the 4 is, or the spaces, and it all comes out. If we want to tell Bash to treat those things as numbers and the plus sign to be a mathematical or arithmetic operation, we can. We put $, double parentheses. This causes the 3 plus 4 to be interpreted as numbers and the plus operator, and it will substitute everything from the dollar to the closing parentheses with the result of doing the math, evaluating the expression, in other words, giving us a 7. It does this as arithmetic on integers. It can have positive numbers, it can have negative numbers. Depending on the version of Bash you're running, that number might be a 32-bit signed number, it might be a 64-bit, it might be 63 bits. If you're going to work with very large numbers, you should do some testing to see what happens. How would you do that testing? You could use the operator for raising one number to the power of another. If we wanted to know the maximum number that would fit in 10 bits, we would do 2 to the power of 10, and it would tell us that that's 1024, 1024. So in 10 bits, we can hold any number from 0 to 1023. If you do this using these number of bits size, how many bits are being used for your integers? If I take 2 to the power of 31, that's the biggest number I can put into a 31-bit space. If I have a 32-bit integer that includes a sign, this is the maximum positive number and the maximum negative number I can have, because one of those 32 bits gets used for the sign, leaving only 31 bits for the number. If I were to check for 2 to the power of 32, and this is a positive number, this means my system, my Bash, can handle positive numbers with a full 32 bits for the number and still have room for the sign. As a matter of fact, on my system, if I go up to 62 bits, I'm still at a nice big positive number. And if I go to the 63 bits, I've jumped to a negative number. That's because this system, 64 bits is used for sign, the other 63 are used for the number. You'll notice when we did 2 to the power of 10, we said that's the numbers from 0 to 1023. If you tried to do 1024 as a number with only 10 bits, you wouldn't get 1024, you would get the maximum negative number. This is known as wraparound. If I take that 2 to the power of 63 and subtract 1, that will give me my maximum positive number, just like 2 to the 10 minus 1 gives me my actual maximum positive number with 10 bits. And you'll see we can actually do a pretty big number on this system. Other systems you do this test on, you might find, are limited to 32 bits. That was very common for a long time. We've used plus, we've used the double star to mean power of. Additional operators are available. The common ones are plus, minus with the dash, multiply with the asterisk or star, divide with the slash, modulus with a percent sign, and there are others as well. If you look at the Bash manual page in the section called Arithmetic Evaluation, you'll see a complete list of all the arithmetic operators. Lots of these things. remember, these are still integers. So if I were to do the arithmetic of 7 divided by 2, my answer would be 3. Now we know that 2 doesn't go evenly into 7. There's actually a remainder. And that's what modulus is for. If we wanted to see the remainder, instead of divide, we would say modulus. It will do 7 divided by 2, and the answer it gives us is not the dividend. It will be the remainder, which is 1. Since everything inside the double parentheses gets treated as a number, if inside those double parentheses we put letters, Bash will assume that those letters refer to a variable name, and it will actually look up the value in a variable, which hopefully will be a number. Variable is a predefined variable that has a random number in it. If I were to put this command in the way it is right now, it's going to get a random number. It's going to divide by 2 and give me the remainder. So each time I do this, it's going to get another random number, and I'll get out as an answer either 0 or 1, depending on whether that random number was even or odd. That time it made an odd number. That time it made an even number, and so on. Modulus is helpful when we want to generate a range of numbers. You'll notice that when we divide by 2, our possible remainders are only 0 and 1, or in other words, a range of numbers from 0 to 1 less than the number in our range, in our divisor. So if I were to take that same number and divide it by 10, each time I do this, my remainder can be anything from 0 through 9. So if I wanted a random number from 1 to 10, I would take random, divide it by 10, take the remainder, and add 1. Dividing by 10 and getting the remainder gives me a result from 0 to 9, but since I want it from 1 to 10, I take from that 0 to 9 and just add 1, which makes it 1 to 10. Now I'll never get a 0, and I may get a 10. Note that some of the characters used for arithmetic, like the asterisk, are actually special characters to the shell for things like file name globbing. Inside the double parentheses, the special meaning of those characters is turned off. When you put a variable name inside the double parentheses, the shell will ignore the $sign if you put one there, because it will already treat that word as a variable. So you can put $random there if you like, or just the word random. In both cases, it means look up the value of the variable and put it here before executing the arithmetic statement. If you wish to do arithmetic with floating point numbers, or numbers that are bigger or smaller than the shell itself can handle, you can still do it in your script. It's just that Bash can't do it directly. So there are commands that we can use that can do other kinds of arithmetic. For example, the basic calculator command is a scripting language, just like awk is a scripting language. And in the language for BC, we can put in all kinds of mathematical formulas and rules about how to handle the output, display the output. We can save data in variables. We can do all kinds of things. It's a scripting language. awk is even more formidable that way. And awk actually includes a lot more data, or a lot more commands on how to manipulate the text inside the script. But as an example, if we wanted to divide 7 by 2 and see the answer with 2 digits of decimal precision, we could say BC and get your input from the command line. And the text should be the command scale equals 2 to get 2 decimal places of precision, semicolon to separate for the next command, and then the actual arithmetic to do, like 7 divided by 2, finish my script. And it will go ahead and run that. So we can do all kinds of arithmetic and mathematics and complicated mathematics in a bash script. We just might need extra commands to do it beyond the basic $, double parentheses that's built into bash.